A rectangle has a perimeter of 36 meters. Find a function that models its area A in terms of the length x of one of its sides. Is it possible for the rectangle to have an area of 72 meters squared? If so, find its dimensions. Is there a maximum area that the rectangle can have? If so, find it. So we want to write a function that models the area in terms of the length of one of its sides. Now, if we have a rectangle and it's got a length and a width, and we want the area, we know that the area is the length times the width. Now, we're told that the length of one of the sides is x. So in our rectangle, the length is going to be represented by x. We need a way to find the width in terms of x. And the thing that we can use here is that the perimeter is 36 meters. We know the perimeter is 2 times the length plus 2 times the width. In this case, the perimeter is 36. We said the length was x, so this is going to be 2 times x plus 2 times the width. When we substitute in 36 for the perimeter and x for the length, we have an equation, and we can solve this for w in terms of x. That will allow us to know what the width is in terms of x, and then we can write area as a function of just x. So we want to get w alone. We can subtract 2x from both sides to move that term to the other side. 36 minus 2x equals 2w. And then to get w alone, we can divide both sides by 2. This gives us 18 minus x equals w. So the width is going to end up being 18 minus x. Another way to think about this, if the perimeter is 36 meters, that means that half the perimeter is 18 meters. So if we look at the length and the width, that's going to be 18 meters in total. And if we've used up x meters for the length, that leaves us with 18 minus x left for the width. So there's a couple of ways that you could get to this conclusion, 18 minus x. Anyways, now we can replace L and W with x and 18 minus x. And now we have the area represented as a function of the length x of one of its sides. This is a perfectly fine answer. We could also write a of x equals 18x minus x squared. Either one of these is a good function for the area. All right. Now we're being asked, is it possible for the rectangle to have an area of 72 meters squared? To figure this out, we replace A, the area, with 72, and then we try and solve the corresponding equation. This is a quadratic equation. We have different ways of solving this. We could try factoring or the quadratic formula, but it's going to be optimal for us to move all of the terms to the same side first. And I'm going to move them all to the left side because then our x squared will be positive, and that makes life easier. So if we move these terms to the left, the x squared goes from negative to positive. So we've got x squared. The 18x goes from positive to negative. And the 72 stays positive. So we get x squared minus 18x plus 72. I've just done a little bit of a shortcut here. If we want to move the x squared to the other side, we need to add x squared to both sides. That's why it becomes positive when it moves to the other side. And to get the 18x on the other side, we need to subtract 18x from both sides. and that gives us a negative 18x. A shortcut here is if we want to move one term to the other side, we just have to change its sign. Anyways, we have x squared minus 18x plus 72 equals 0. We can either try factoring or the quadratic formula. I don't want to use the quadratic formula because those numbers would be super big, like b squared would be negative 18 squared. So let's try to factor. We're looking for two numbers that have a product of 72 and a sum of negative 18. Well, the two numbers are going to have to be negative if they multiply to be a positive but add to be a negative. Can you think of two numbers that have a product of 72 and a sum of negative 18? Well, those numbers do exist. They are negative 12 and negative 6. So we've got x minus 12 times x minus 6 equals 0. We can now set each of these factors equal to 0 and solve. And when we do that, we get x equals 12 or x equals 6. Now, if we choose 12 to be the length here, then the width would be 18 minus 12, which would be 6. And if we choose 6 to be the length, then the width is 18 minus 6, which is 12. So whichever one of these we choose to be the length, the width is just going to be the other. So in the end, our answer is that yes, it is possible, and the dimensions are just going to be 12 meters by 6 meters. So yes, it is possible, and the dimensions are 12 meters by 6 meters. That will give us an area of 72 meters squared. Now the last question we were asked, is there a maximum area the rectangle can have, and if so, find it? Now I want to look at the area function here. This is a quadratic function with a leading coefficient that's negative. We know that its graph would then be a parabola that opens downward, and sure enough, there is going to end up being a maximum area because this parabola will have a vertex that's going to correspond to a maximum function value. So we need to find that. I'm going to rewrite our function over here. The area is 18x minus x squared. And I'm going to rearrange the terms so that that negative x squared is out front. That ends up being a little bit nicer. Now, to find the maximum area, we basically need to find the coordinates of the vertex, and we have two ways of doing that. We can complete the square here, and that will give us the coordinates by putting this in standard form for a quadratic function, or we could use the formula that tells us that the x value is the opposite of b over 2a. You could really use either method. I'm going to use this shortcut here. So in this case, b is 18. So the opposite of 18 is negative 18. And a is negative 1. So 2 times negative 1 is negative 2. Negative 18 divided by negative 2 is positive 9. So the maximum is going to occur when x is 9. And to figure out the corresponding maximum area, we evaluate the function at 9. So this is 18 times 9 minus 9 squared. We could use either of these to evaluate the function. We could even use this formula. All of these equations are equivalent to each other. Anyways, 18 times 9 is 162, and 9 squared is 81. And 162 minus 81 is 81. So the maximum area that the rectangle can have is 81 meters squared. Yes, there is a maximum, and that is it.